Alright. Okay, so welcome to another live stream. This isn't probably gonna be more than half an hour to the most. I want to start actually doing reviews on papers from arXiv, machine learning papers, because I think it's really important to actually understand the implications, at least for now, when it comes to NLP language models, because few people actually understand the magnitude of this freaking stuff. So very big companies like Facebook, OpenAI, Google, and others are training natural language processing models, even Google with their search engine, and they actually feed these models like hundreds of gigabytes of data, and nobody actually knows accurately what happens as these models learn. So one of the most important thing nowadays, or one of the most important things when it comes to advancing this type of research, is to actually being able to understand, or being able or having the ability to actually take information, take precise or take the kind of information that you want from these models. Now in this case, it's really important to say that junk in, junk out. So if you put junk in, of course it's going to be hard to actually leverage quality stuff out of these models. So that being said, this actually is going to be viewed by more people. Right now I think it's only myself. If there's anyone else here, just say hello in the chats. But more people are going to actually see this live stream in the future, in the near future. So the actual purpose of this video is to start reading and going through this paper, the pile, which is an 800 gigabytes data set of diverse text for language modeling. And this has been published in the beginning of 2021, I believe, even though here it's 31st December 2020. I think it was published 1st or 2nd of January by EleutherAI. Now, a little bit of background of what happens here. So EleutherAI started creating a model which is called a natural language processing model, which is called GPT-Neo. So they actually did this sort of like, as far as my understanding goes, as a response to the GPT-3 closedness, or not necessarily closedness, but as a response to the fact that a lot of people wanted to actually work with the GPT-3 and haven't been able to. And if we look at the GPT-3, so this pile, the pile which is the data set that has been used to train the GPT-Neo, the GPT-Neo models, this is a very, and we're gonna get into it shortly. This is in my view, is a very high quality, carefully crafted data set, and I would sort of like to do a little bit of a critic when it comes to the GPT-3 itself. So if we look at the GPT-3 Wikipedia, we can understand the type of data. So we can do a little bit of a comparison to the type of data that GPT-Neo and GPT-3 have been modeled. So if we look at the GPT-3, we know that GPT-3 has 175 billion parameters, which is astronomical. In 2021, there have Google, I think, has been published a paper on a model which is called a switch transformer, which has 1.3 trillion models, if I am correct. So that's another order of magnitude. It's going to be interesting what happens with or what are the implications of actually using that switch transformer. Anyways, so if we look at what GPT-3 has been supposedly trained on, should be somewhere around here in the capabilities. Yeah, so 60% of the weighted pre-training datasets for GPT-3 comes from a filtered version of Common Crawl. This is actually, even though it's a filtered version, this is actually web data, and it might not be the highest quality, and having 60% of the data that has been used to train this model from Common Crawl isn't the best thing in my view. Now, this might not weight as much because even though it's 60%, they actually trained other sources for multiple times. Like, other sources are 90 billion tokens from web text, which is 22% of the weighted total. So 410 billion tokens. Then we have 19 billion tokens from web text. And then 12 billion tokens, which is quite a little bit, from books, which is a data set containing books, and 5 billion tokens from books too, which is another 8%. 3 billion tokens from Wikipedia, representing 3%. And this is just about it. Now, when it comes to, so in my view, this isn't the best high quality data, but still, you can get a lot of good information. And as of recent, I've received an invitation to be part of a team on GPT-3, and I've actually started playing in the playground, and we might get into this in a future video, but this is actually really interesting, and the folks at OpenAI are actually doing an amazing job when it comes to the engines that they give or that they have available for the GPT-3. And I'm really fascinated about the instruct beta languages, because you do not necessarily have to provide a shot or a few examples of what you want for the GPT-3 to actually fill in or generate text. You can just start asking questions in natural language, and that's pretty freaking amazing. And from my understanding, the DaVinci Instruct Beta is a recent addition. Now, one critic to OpenAI and GPT-3 is the fact that the date of the data, which is has gone into GPT-3, I believe, is 2019. So it doesn't have knowledge of current events, and I hope OpenAI is going to change that and actually add more recent events for or inside the data that powers GPT-3. Now, this video isn't about GPT-3, but this is about EleutherAI and the Pile dataset. So we have the EleutherAI, and we have the GPT-Neo, and we have the Hugging Faces GPT-Neo, and compared to GPT-3, GPT-Neo, the largest model of them, has 2.7 billion parameters, while GPT-3 has 175 billion. So GPT-3 has like 80 or so times as much parameters compared to the Neo. But what I want to actually highlight here is the fact that the quality of the data that has been used to train the GPT-Neo, all of these models, is really, really good. And let's actually start looking into this paper. So as you can see, is a transformer model designed using EleutherAI's replication of the GPT-3 architecture. So what they're actually trying to do is to replicate the GPT-3 architecture. And this is also an autoregressive model, should say somewhere over here. So this model was trained 400,000 steps on the pile, and it was trained as a masked autoregressive language model using cross-entropy loss. So this is actually what they did to train the data. So 2.7, the number of parameters, 2.7 billion parameters of this particular pre-trained model. Curated dataset. So the pile is a large-scale curated dataset. Now let's actually look into the paper. So this is, I believe, this is the team at EleutherAI, and recent work has demonstrated that increased training dataset diversity, and we're actually going to see this just a little bit below. Improves general cross-domain knowledge and downstream generalization capability for large-scale models. So this actually means that the more diverse the data set you have, they infer that the better generalization capability of the model will be. Now, with that in mind, they present a pile which is constructed from 22 diverse high-quality subsets, many of which derive from academic or professional sources. So their evaluation of GPT-2 and GPT-3 on the pile shows that these models struggle on many of its components, such as academic writing. So they're actually saying here that models trained on the pile improve significantly both over raw CC and CC100 on all components of the pile. And we'll see what these two actually mean in a little bit. We make publicly available the code used in its construction. That's why I love EleutherAI. Yeah, so CC is actually the common crawl. The growing need for data in language modeling has caused non-existing large-scale language models to turn to the common crawl for most or all of their data. Training on the common crawl has been effective. Recent work has shown that data set diversity leads to better downstream generalization capability. Okay, so because of that, they actually proposed or introduced the pile, which again has 22 diverse and high quality data sets. And these are actually the sources or data sets, or the sources for the data set. So we have PubMed, Archive, both of them are research study aggregators, GitHub, probably for code, the Free Law Project, probably for law. We have Stack Exchange for technical debugging. We have Patent and Trademark Office. I didn't actually pay attention to this one. Then we have PubMed. Once again, we have PubMed Central and PubMed. Ubuntu, Hacker News. I'm not sure how Hacker News is a very high quality one, or YouTube. Then we have Phil Papers, I think is Philosophy Papers, and NIH Exporter. They also have Open Web Text 2 and Book Corpus, which are extensions of the original Open Web Text and Book Corpus. Now they also introduced Books 3, Project Gutenberg, which is actually probably another Books one, Open Subtitles, English Wikipedia, Mathematics, EuroParl, this is probably Parliament, and we also introduced a new filter subset of Common Crawl, which is PyLCC. This is probably their own version, their own curated version of the Common Crawl with improved extraction quality. Now the tree map of the Pile components by effective size. So if we look at these are academic, this is the internet, this is prose, this is dialogue. This actually, the dialogue feature, I believe, actually helps for chat and Q&A probably. Then we have miscellaneous, which is GitHub and DM Math. So in this case, I see it as a multi-purpose. So you take out of all of them, you have very academic and scientific knowledge at hand if you know how to query the EleutherAI GPT-Neo, and then you also have web data, which is popular wisdom, if you can call it that way. Maybe Open Web Text 2 and Stack Exchange, maybe PyLCC as well, but Wikipedia is actually I would say it's a very good curated source of accurate information. So we have like a small portion from Wikipedia, which is nice, but we have a very large portion from PubMed Central. And then we have books here, we have GitHub, this is like code, and then we have dialogue stuff. Okay, and we'll actually I want to do this video in two parts. This is actually the first part, which we're gonna finish like quite soon, and then in the second part, which is probably tomorrow or in the next couple of days, we're actually going to finish with this paper and then move on to some other papers that we have here, which I didn't actually get the chance to read thoroughly. This is prompt programming for language models. Prompt engineering is going to be one of the most important jobs of the future, and I'm going to expand when we get to this paper, which was published just recently. Now we have the composition of the pile by category, so you can understand what goes inside the pile model. So this is going to be very important when you are actually trying to extract information from the pile, whatever your use case may be. Like for example, when you're querying one of these models, like the pile has been touted as being used for text generation, but I believe that you can use it for other purposes as well, like we have in this case not only text generation, but you can probably use it for summarization task, and also for the rest of them that Hugging Face presents here. And we'll get into this in future videos. Now, going back to the paper, this is where they say they make a publicly available processing code for the constituent datasets of the pile. So this is actually how they pre-processed the datasets, which I think is really interesting. And for reproducibility, they also document how they pre-processed each dataset. And that's actually section 2 and section 3 of this paper, and we'll actually get into it probably in the next video. Now, what we know. We have the 825 gigs pile consisting of 22 diverse sources, which I think it's already going next level compared to GPT-3. Of course, it hasn't been trained as extensively, in my view. Even though they say that they have significant improvements across many domains compared to GPT-2 size models. Now, one very important table here. Let's see how we can understand this. So we have each component or each data set in this case. So the pile CC comprises of 18% of the entire pile data set. So quite a big chunk, almost a fifth out of it, but this has only been trained for one epoch. And we're also getting the mean document size, which might not be as important. So we have the weight, we have the epochs, then we have the effective size. Now you get the effective size by, I think, multiplying the raw size by the epochs. And that's right, because you have PubMed Central. Now, for every epoch, and in this case, we have the 2.7 billion parameters. One was trained for 400,000 steps. I believe these steps are epochs, if I'm not wrong. So for each epoch of the pile, CC, PubMed Central has been trained twice. This actually makes it, the raw size is 90 gigabytes, and then you have the effective size, which is 180. We also have books which have been trained more than one epoch. So this is actually the weight, the effective weight. The effective weight, the effective size is 151 gigabytes, and the effective size, so the effective size is 151, and the effective weight would be multiplying the weight by the epochs. So 12 times 1.5, the effective weight would be around 18%. Which is similar to the pile CC. So that's actually really good, because it weighs more on academic and prose versus common crawl, which is a popular culture, if I can put it that way. So we also see that Archive, which is an aggregator of scientific papers, has been trained for twice, GitHub only once, Freelaw 1.5, Stack Exchange, PubMed Abstracts, 2 epochs, Gutenberg, this is for books, 2.5, Wikipedia 3. So Wikipedia gets a lot of weight in here. Also mathematics. Now see why I'm saying that this is a well-curated dataset for the GPT-Neo transformer model, and we'll actually go and demonstrate how GPT-Neo works in future videos. I have an API key for the Hugging Face, so I don't have to actually download the model on my local machine to actually run it. I can just query the model using the Inference API, and you have a demonstration here of the inference of the API, and you can just compute it. It's going to take a little while until it probably loads the model from cache. But it's gonna give a completion, so it's gonna generate text. But of course you don't have too many degrees of freedom when it comes to controlling the parameters. Like for example, there are quite a few parameters that you can play with when it comes to generating text. Like for example, you have parameters like top K, top P, temperature, repetition penalty, num return sequences. All of these are important parameters because on these parameters depends what you get out of the model. And aside of these, there is also a max length. So in this case, you cannot, as you can see, the most that you get is maybe 2 or 3 sentences. But if you can play with the model parameters, like for example max length, you can generate lengthier, more precise outputs, or outputs that are actually in correlation with what exactly you want. For example, you can play with the temperature parameter. If you tune the temperature parameter closer to 0, it's going to give you sort of like the same answer. While if you set the temperature parameter very high, it's going to give you, if you have a lengthier output, it's going to give you very chaotic response. It's interesting. I mean, a lot of people have been using higher temperatures to actually create very creative texts. For example, poetry. I would say that you can generate nice poetry with having a temperature set quite high, but we'll look into this in the future. There you have the hosted Inference API, and you can use this in transformers, which is exactly how I'm actually using it, or you can use the accelerated inference. If you use it in transformers, this actually means that you're going to download the model on your computer, and the GPT-Neo 2.7 billion parameters is 10 gigabytes of data. And to actually get information out of this, like for example to generate a 200 token response, could take maybe 2 to 3 minutes. But if you are using their accelerated inference, so I'm actually paying for this, it's cheap. It's quite cheap. It's $9 a month, and you get to have like, I think it's 1 million tokens or something. Yeah, it's probably 1 million inference input characters, because this one is 10 million. I'm not exactly sure. But if you use the accelerated inference with your API key, then the response that you'll get, like the same response that it would take 2 minutes on a high quality GPU, maybe their accelerated inference would take 10 to 15 seconds, which is really good, because if you want to generate text that's 500 tokens long, that's maybe less than a minute compared to what you would have to pay or what you would have to wait on your laptop or on a instance like, for example, on Paperspace or on Google Cloud or on other VPS providers. But anyway, getting back to here, let's see, how are we on time? So it's already 32 minutes. I'm gonna spend a couple of more minutes and then actually finish this one, and we're gonna continue with the next live stream. We're gonna continue in the next live stream with the rest of the paper. This is 39 pages long. I'm not sure if we're gonna be able to finish it in the next maybe it's gonna take more than 2 parts, but I'm gonna try to be more concise in our next live stream. So we can see that PileCC is a collection of website crawls from 2008 onwards. Now, what I want to point out here is that, as I've said in the beginning of this video, GPT-3 knows data or has been trained on data up to 2019, if my understanding is correct, while GPT-Neo, this one, has been trained on data as recent as 2021, which is extremely important because GPT-Neo has knowledge of very recent events compared to GPT-3, and this is really important when it comes to academic implications or research implications, medical implications, physics, math, and other areas of science implications. Now, PileCC, due to the raw nature of the data set, you're getting information from diverse domains, but at a cost of varying quality. And they did well-designed extraction and filtering. Yielding higher quality output than extracted plain text. Now we have the PubMed Central. Most publications indexed by PMC are recent, and their inclusion is mandated for all NIH-funded research starting 2008. We included PMC in the hopes it will benefit potential downstream applications to the medical domain. So I'm actually really looking forward to explore GPT-Neo, the 2.7 billion parameter ones, when it comes to medical applications, because there is a lot of information in here. There is a lot of unknowns. So this has 2.7 billion parameters, and God knows what this model has learned for 400,000 steps that has been trained on the pile. So it's gonna be interesting to try to extract high quality information, and we'll definitely dive deep into that in future videos. For medical purposes, this is gonna be a hard and very challenging task, because we'll have to leverage on the best configuration of these parameters, and maybe the folks at Hugging Face are gonna give us other parameters that we can play with, because not only top K and top phi, but there's also, other than the repetition penalty, there's also a presence penalty, and there are more parameters that you can fine-tune to get the type of information that you want. Like, for example, if you want creative stuff, you would tune these parameters in a certain way. That's why I'm talking about not only parameter tuning, but also prompt tuning. And the prompt that I'm talking about is what you're giving as an input to the model. We'll be looking into this in future videos. For now, we have the PubMed Central, and then we have books 3. This is quite recent. We have a mix of fiction and non-fiction books, and is almost an order of magnitude larger than our next largest book data set. We included bibliotic because books are invaluable for long-range context modeling research and coherent storytelling. Okay. Now we have Open Web Text, which is another web scrape dataset inspired by web-to-text. This is Reddit information, might not be the highest quality one, but they might have curated it in a way in which they increase the quality. Then we have Archive, in the hopes that it will be a source of high quality text and math knowledge, benefit potential downstream applications to research in these areas. So I'm really interested in Archive. Try to see how we can get good insight from Archive and PubMed. Maybe books when it comes to creative tasks such as storytelling, and why not poetry, who knows. Then we have GitHub. I'm interested in seeing how we can generate quality code. We're gonna see if we can generate some Golang and Python code. Okay, so we're gonna stop here, and then we're gonna keep on with reading and going through this paper in the next video. Please excuse the background noise. Alright, so if there are no questions, and I think I'm the only one here right now, even though it says that we have two concurrent viewers, whoever is here and doesn't talk to me, you should be ashamed. Okay, we're gonna proceed with this the second part of the pile paper in the next video.